All right, so this is the metric system, meters, grams, and liters. I'm your teacher, Mrs. DeBose. As always, the first thing you're going to do is take out a sheet of paper, put a proper heading in the upper right-hand corner. First, last name, period, that you have me, and the date. We're going to be the metric system, obviously, and we're going to learn when we use it and how it's used. The first thing to know about the metric system is that the metric system is a measurement system based on our decimal number system. So it's based on tens. It uses a base 10. All right. Other countries all around the world use the metric system in their daily lives. Okay, so they don't talk about how things weigh pound and ounces, but they talk about grams. They don't measure things, distances in miles. They don't measure height in feet, but rather in meters or kilometers. And they do not measure capacity of an object in gallons and quarts and pints, but instead in liters. So those are the terms we're going to be hearing: meters, liters, and grams as we go throughout this presentation. And know that wherever we are in the world, though, scientists, engineers, they use the metric system because it's universal and because it's simpler. It uses a base 10 method, and it's more consistent, so it's easier to picture things and to visualize things when we understand it's going up by multiples of 10, or either it's decreasing by tens. And we'll see how this works later on. All right, so look at this chart here which shows us the abbreviations for the metric prefixes, and it also has the metric prefixes themselves also. It also gives their value, and it tells you what that value is worth in terms that we are familiar with. So let's start here at the bottom. Milli, symbolized with an M, and that is 1/1000th of the base unit of 1. And we'll get to that in a second. Centi, and certainly we've heard the terms like centimeter, centiliter, centigram before. 0.01, which is the hundredths place. It's 1/100th of a base unit of 1. Deci, like a deciliter. 0.1, or 1/10th of the base unit. Now the base unit is a little bit more confusing. That's your one. That's your one whole. Meter, liter, or gram. All right, and if you go above the unit of measure, we start counting up in values of 10. Deca, 10. And if you multiply 10 to 10, what do you get? 100. Well, that's what your hecto is. It's 100 times the base unit of 1. And kilo, like kilometer, is 1,000 times the base unit of 1. Here's another way of looking at the metric system, the staircase method. You have kilo all the way down to your milli. All right? And it shows the value too. So kilo is 1,000 times that basic unit. Hecto is 100 times the basic unit. Deca is 10 times the basic unit. And then below the basic unit, we get into those fractions of the basic unit. Instead of being multiples of the basic unit, like kilo, hecto, and deca, below the basic unit, you have things that are a fraction, or just a portion of the basic unit. So a deci is 1/10th of the basic unit. Centi is 100th of the basic unit, and milli is 1,000th of the basic unit. Now let's look at the individual forms of measurement, or units of measure. Okay, there's meters. Meters measure length or distance. 1 milliliter is about the thickness of a dime. And once again, we know this millimeter that we're looking at is 1/1000th of 1 meter. 1 centimeter, or 100th of 1 meter, is about the width of a large paperclip or your fingernail. All right? So if you have 100 centimeters, you have 1 meter. And 1 meter, which is the base unit, is about the width of a doorway. Those are the meter sticks that your teacher has in the classroom. Not a yardstick, but a meter stick. It's just a little bit longer than a yardstick. A kilometer, or kilometer, is about 6 city blocks or 10 football fields if that's easier for you to picture. All right? Once again, the staircase method. Understand that kilometer we just looked at, our kilometer, is 1,000 times the basic unit of 1 meter. So that meter stick your teacher has in class, you get 1,000 of them together, and you have 1 kilometer. Okay, so grams are next. Grams are used to measure the mass of an object. And before I talk a little bit more about grams, let's have that first question. So in your left-hand margin, put the number 1, and here's your question. Why do scientists use the metric system? Why do scientists use the metric system? Why don't we use the standard system, which is what we use in the United States, pounds and gallons and quarts, miles? Why do we use the metric system instead? Meters, liters, and grams. Why do scientists always use, even in the United States, use meters, liters, and grams? All right, so grams measure mass. Mass is not the same thing as weight. People often get them confused. And in fact, this presentation used the words weight, but it's actually a measurement of mass. And we'll talk about that later on in the year. We'll learn about mass and what the difference between mass and weight is. All right, so a milligram weighs about, or has a mass of about a grain of salt. Very, very tiny, which is another reason why scientists love to measure with the metric system, because it allows to measure something as tiny as a milligram, the mass of a grain of salt. Very tiny. 1 gram, which is the base unit, a gram, weighs about as much as a small paper clip. That's still pretty small. But 1 kilogram, 1,000 times a base unit, weighs about as much as 6 apples or 2 pounds. So if you get 1,000 of these, you have the same as this, 6 apples. Once again, here's that staircase method. It really lets you see that using the metric system, it decreases by 10. Each unit of measure from kilo to milli. And we need to know these in order. Kilo, hecto, deca, base unit, which is your meter, liter, or gram, depending on what you're measuring, deci, centi, and milli. Okay, so liters. Liters measure liquids or capacity. When we think of liters, we think of going to the store and grabbing your favorite soda. 1 milliliter, or 1,000th of a liter, which is the base unit, a liter, is about the amount of 1 drop from an eyedropper. Tiny, tiny bit. So if you get 1,000 of these, you have 1 liter. Now 1 liter, which is the base unit, is about half of a 2-liter bottle of Coke, obviously. And a kiloliter, the large one, 1,000 times the base unit of liter, would be about the volume of a small hot tub. So if you get 1,000 of those liters of Coke from the grocery store, a 1-liter Coke bottle, you have enough to fill up this hot tub, or about. Now, you don't need to write this down on your sheet of paper, but I want you to think about what unit you would use to measure each of the following items. This bicycle. All right. What unit would you use to measure the length of this bicycle? Kilometer? That's 1,000 times the base unit of a meter. 1 meter, that's the base unit. Centimeter? That's 100th of a side of a meter. In other words, if you take 1 meter and break it up into 100 parts, it'd be one of those parts. Would I use centimeters to measure this bicycle? Or millimeters? 1,000th of a meter. Just think it in your mind. Which would you use to measure the bicycle? Okay, Which unit would you use to measure the mass of a penny? It's important. Let's key on this word unit. Unit of measure means the type of measurement that you use to measure an object, whether it's liters, meters, grams, centimeters, kilometers, centigrams, milligrams. We always denote the unit of measure. So kilometer once again. Would you measure the mass of this penny using a kilometer? A gram, that's the base unit, 1 gram. A centiliter, that means 1/10 of a liter. Or a milligram, that means 1/1000th of 1 gram. Now some we can get rid of right away because we know that that unit of measure, a meter, gram, liter, may or may not be used to measure mass. So go back and review the other slides if you have to. Which unit of measure is used to measure mass? And you can get rid of a couple of these right away. So once again, figure it out for yourself. Which would you use to measure the mass of a penny? All right, so let's look at the staircase method, and it's time for question number 2. So put 2 in that left-hand margin, and here's your question. What do liters measure? What are they used to measure? We talked about length, we talked about distance, we talked about capacity and volume, and we talked about mass. What are liters used to measure in the metric system? All right, so here they are in order. And a good way to remember the prefixes to the metric system is to think King Henry died unexpectedly drinking chocolate milk. That's your kilo, hecto, deca, unit of measure. Very important. We can't forget that base 1, unit of measure. 1 meter, 1 liter, or 1 gram. Deci, centi, or milli. All right? And also it's important to note that milli means 1,000th. Centi means 100th. Deci means 1/10. Deca means 10. Hecto means 100. And kilo means 1,000. The prefixes are exactly what they equal. Now, I have on the next slide, and the several slides hereafter, about 10 slides or so, the story of King Henry. Now, why am I talking about social studies or history and science? Because there's a very interesting story about King Henry that most people don't know about that will teach you about the metric system and knowing those prefixes in order and their value. So if you look over the next slides, and I'll let you do that on your own, I won't be narrating them, you'll learn a valuable lesson. It will help you remember King Henry died unexpectedly drinking chocolate milk. Kilo, hecto, deca, unit of measure, deci, centi, and milli. All right? Thanks so much. Please read through those and help you remember the metric system.